Okay, one thing I should have done in the last video, I wanted to put these or plug these values back into the original absolute value equations, just to basically show you that these in fact are the values that x should be for this absolute value statement to be 7. Let me start over again, starting here. All right, one more thing I want to do in this video that I should have done in the last video. I want to plug these values back into my original equation just to check my work. Okay, so for case 1, I'm going to plug in x equals 4 back into this absolute value equation and make sure that in fact it does equal 7. So here's my case 1. I'm going to plug in 4 for x. Let's see, 2 times 4 minus 1, the absolute value of that. Does that in fact equal 7? Let's see. Work inside the absolute value bars. 2 times 4 is 8. 8 minus 1. Does that in fact equal 7? Let's see. What is the absolute value? 8 minus 1. Well, 8 minus 1 inside this absolute value, or the absolute value bars, is 7. So is the absolute value of 7 7? Yes, it is. The absolute value of 7 ends up being 7, and 7 does in fact equal 7. Let's look at case number 2. This time I'm going to plug in negative 3 inside this absolute value equation and see if it is true. Let's see. Rewrite this. Absolute value bars. 2 times negative 3 minus 1 equals 7. Let me work inside the absolute value bars here. See, 2 times negative 3, that's negative 6 minus 1. Absolute value bars, put them back. Okay. Let's see, negative 6 minus 1. Well, that is the absolute value of negative 7. Does negative 7 equal 7? Well, we know it does because, again, remember, absolute value is the distance from whatever's in here to 0. The distance from negative 7 to 0 is 7. So 7, again, does in fact equal 7. Therefore, I did find both cases that make this absolute value equation true.